In just 24 hours, humanity will begin its greatest adventure, the establishment of an outpost on the red planet Mars. Now humans will finally journey to another planet, a planet where life once may have existed, the planet our ancestors named for the god of war. It's taken us a long time to get to this historic day, but we won't be the planet's first visitors. Robots originally explored the red planet during the Mariner program in the 1960s. Mariner 9 of that series discovered 4 majestic volcanoes. The tallest, Olympus Mons, is the largest volcano in the entire solar system. Mariner 9 also found an enormous canyon system, now called Valles Marineris. These canyons are more than 3 times as deep as the Grand Canyon and as long as the United States is wide. The Mariner spacecraft also photographed giant dust storms, polar ice caps, and river channels, channels which once were cut by running water. Robotic landers followed during the next decade and led to a spectacular first look at the Martian surface on July 20th, 1976. That's when the Viking 1 lander separated from its companion orbiter and began its descent to the western edge of Chrysoplanitia, the Plain of Gold, near the edge of an ancient channel where water once flowed. Millions of people shared the first images with excited scientists at the Jet Propulsion Laboratory in Pasadena, California.
Tantalizingly thin sliver of picture.
Yep, that's it.
New rocks.
Oh, that's beautiful. May not look like much, but it's lovely. Oh. Yeah, I'm supposed to say something at this point. I just don't feel like talking.
Well, there are rocks.
There are rocks, yes. There's rocks and there's sediment, but it's just incredible to see that the Mars, is really there.
Over 20 years would pass before we'd make our return to Mars. But when we did so with a vengeance. Starting in the late 1990s, orbiters, landers, and sample return missions have studied the planet intensively. We've sent 1 or 2 spacecraft every 26 months to investigate how the planet's geology and climate have changed over time. We've also searched for evidence of present or past life on Mars, a prospect that has captured the imagination of humankind for ages. As the landers were studying the surface of Mars, scientists began analyzing a group of unusual meteorites discovered on Earth. And what a surprise they found. They discovered that trapped gas within these rocks has the same chemistry as the Martian atmosphere as measured by the Viking landers. The scientists then concluded that these meteorites must have come from Mars. So how did they get to Earth? Well, millions of years ago, giant impacts blasted these rocks from Mars and into the inner solar system. Eventually, a few reached Earth's surface as meteorites. Inside some of these Martian meteorites, scientists found fascinating evidence of possible ancient life forms, visible only with the most powerful microscopes. This ongoing search for past or even present Martian life is the major research focus of the crew who will lift off tomorrow, the crew of Antares.
The Antares mission actually began 2 years ago with the launch of 3 support spacecraft. Antares 1 is a fully fueled Earth return vehicle. Currently in orbit around Mars, Antares 1 is ready to bring our astronauts home in 2 years. Antares 2 is the ascent vehicle, which will ferry the astronauts from Mars to the return vehicle. It is already in place at the crew's landing site. Its power plant is in good working order and has been producing fuel for the crew's liftoff from Mars. It's also producing extra oxygen for the astronauts to breathe. Antares 3 includes the laboratory where the crew will live and work, and the rover, which will transport the scientists as they explore the planet. The lab and rover are ready and waiting for the arrival of our astronauts. To prepare for their journey to the Red Planet, the Antares crew has trained together on the International Space Station, practicing every maneuver and rehearsing every emergency as a well-coordinated team. An Earth-to-Mars communication delay of up to 20 minutes increases the need for self-sufficiency. Training for long-duration spaceflight was a major focus of the Russian space station Mir and pioneering astronauts like Shannon Lucid. Dr. Lucid's 6 months on Mir equals the same time period our astronauts will spend in transit each way to and from Mars. We are proud to introduce the men and women who will walk on Mars. Our commander has primary responsibility for all spacecraft systems in transit and on Mars. Our pilot is in charge of vehicle dynamics in space and rover operations on the Martian surface. Our geologist is a veteran astronaut who has been analyzing rocks and soils from Mars for over a decade. For the last 10 years, our mechanical engineer has maintained life support systems and has controlled robots in Antarctica and on Mars. Our flight surgeon is responsible for crew health and is an expert in performing surgical procedures in microgravity. Our life scientist will focus on the collection of samples that could provide evidence of past or present life on Mars. These astronauts will be on their own more than any astronauts in history as they leave the cradle of planet Earth to step out onto a new world.
Launchpad A, May 11th, 2018.
T-minus 30 seconds and counting for the launch of Antares 4, the first human mission to another planet. Weather downrange is calm and clear. Fuel pressure nominal. The gantry has been retracted. We are go for launch. T-minus 10 and counting. 8, 7, main stage ignition. 4, 3, 2, 1, 0, liftoff. We have liftoff for Antares 4 on its 2-year mission to the planet Mars. This is Mission Control, Houston, confirming Earth orbit.
Antares 4, you are clear for trans-Mars injection and a rendezvous with destiny on the red planet. See you back here in 2.5 Earth years. Farewell and best wishes from your home planet Earth.
Commander's Briefing, May 2018.
In our last real-time broadcast from the flight deck of Antares 4, we'd like to explain where we're going for the next 30 months. For now, Mars is just a tiny speck over 100 million kilometers away. But in 6 months, we must land in an area just 2 kilometers wide. This is navigation at its finest and most dangerous. We have already left Earth orbit on a gradual curving path as shown here. And in 6 months, we will ease into a Martian orbit. Once we reach Mars, it will be almost 18 full months until Mars and Earth come into alignment again so we can start home. And then we will ease out of Mars orbit, allow the faster orbiting Earth to catch up with us. Our trip will be 200 days each way, with 550 days spent on the surface of Mars. This fast transit minimizes the health risk during the flight and maximizes our research time on Mars.
Surgeon's Briefing, June 2018.
Welcome to the flight deck of Antares 4. Nothing compares to this feeling of weightlessness. Our clumsiest astronaut turns into a graceful gymnast. Every motion is play. Even the frustrations of flying food and floating hair add to the fun of microgravity. Yet these effortless feats do little to exercise our lazy muscles. As the months of weightlessness pass, our bones will gradually lose calcium, a deterioration that should stop under the gravitational influence of Mars. Right now, motion is so effortless that our muscles will weaken from disuse. The heart and circulatory system relax since they no longer have to pump blood up against gravity from our legs. To ease our adaptation to Martian gravity, we must exercise over 2 hours each day. 1 hour walking on the treadmill, and 30 minutes of treadmill jogging, plus 30 minutes on the exercise bicycle. It's my job to cheerlead this daily drudgery.
Geologist Log, November 2018.
For the last 2 months, we've watched Mars grow larger and strained to see each new feature. Recently, the planet's white polar caps and 2 small moons have come into view. As we get closer, I can almost make out the equatorial canyons of the Valles Marineris and the 4 great volcanoes of Tharsis Plateau. After 6 months in a cramped tin can, it's wonderful to see a planet surface again. We're all suffering cabin fever. Humans definitely need their space, even in space. Soon we're going to land in the oldest region of the planet. We are aiming for Dao Vallis, the Valley of the Star, northeast of the Hellas Planitia. Floods of water carved this valley over 1 billion years ago. A nearby volcano, Hadriaca Patera, probably created the canyon by melting underground ice. The combination of water and heat have made Dao Vallis a place of great interest to both geologists and biologists. This is one of the best locations on Mars to search for signs of ancient life.
Commander's Report, November 2018.
We're on our way down and ready to receive telemetry from the robot rover below us on the valley floor. That robot should be focused on that point in the sky where we're soon going to be. The robot's pictures are coming through, and golly, we're right on target. That homing beacon on the valley floor is sending us its signals. Our goal is to touch down just 1 kilometer from the Antares 3 lander already on the ground at Dao. Everything, everywhere we look, is varying shades of red, from dark oranges to rusty brown. And those canyon walls that we saw in the photography are now rising above us in the distance. Dao Vallis is waiting and we're on our way. It's a homecoming to a place that we have never been. Touchdown, Houston. This is Dao Vallis. Antares 4 has landed.
In another 8 minutes, traveling at the speed of light, that news will reach Mission Control in Houston. Light Scientist Log, December 2018.
Gauge readout complete.
Suits clear.
Go for EVA.
My feet touch the bottom rung of the short ladder and the Martian soil below. The words of Neil Armstrong echo in my mind as I repeat the words we have all agreed to say. This is the second giant leap for all humanity, another small step toward our destiny in space. I am standing in the dust of Dao Vallis, millions of kilometers from my home on Earth. I try to imagine Mars as a world where life once flourished, with a warmer climate and more abundant water. This valley was carved by running water, like valleys back on Earth. But this is like no place on Earth. No plants fill the spaces between the rocks. No insects crawl on the dusty sand beneath my feet. None of our machines have been able to answer the question we have come here to resolve. Did life once exist here? We will collect samples and search for fossil evidence of ancient life. We may even find living microbes that have endured for millions of years. A remote possibility, but one that excites me most of all. I grew up fascinated by the possibility of life in the universe. So I'll never forget the day in elementary school when I saw a planetarium show simulating a trip to Mars. Our teacher told us that the first astronauts on Mars would be our age. I was determined to be on board. I wanted to be there, and now I am. I wonder if my teacher is watching. For now, I am simply amazed to be here. In astronomy, you learn about nebula, stars, and planets too distant to touch. But now, here I am, touching another world.
Engineer Meteorologist Report, January 2019.
My job as engineer is to make sure the mechanics of the mission work properly. Our lives will depend on it. Our first priority on Mars is to link the Antares 4 lander to the lab already on the surface. Both modules have wheels. We will simply drive them into place and connect the airlocks. Over there is our propellant plant. It's been in operation for over 2 years now, combining carbon dioxide from the air with hydrogen to produce water and methane. We can then extract oxygen from the water, and we will use both methane and oxygen to fuel our ascent stage when we leave Mars. That new surface lab contains a large storage area with waste management and air recycling on one level, and a second level for science and research labs. As we use up supplies, the extra storage area will also be used as a greenhouse. Eventually, we hope this greenhouse will produce about 10% of our food, real fresh vegetables, after months of prepackaged meals.
Surgeon's Log, February 2019.
The crew has dealt well with the transition to Mars gravity. Our in-flight exercise seems to have paid off. My main concern right now is radiation. Beyond Earth's protective magnetic field, atmosphere, ozone layer, and Van Allen belts, we can be exposed to dangerously high radiation levels from the Sun and from galactic cosmic rays. Neither our spaceship nor the Martian atmosphere can fully compensate. Radiation risk monitors must be worn at all times during the mission.
Engineer Meteorologist Log, March 2019.
We have begun to notice differences in our valley with the coming of winter. Each winter day, we wake up to temperatures hovering around 100 degrees below and begin our work, thankful that we are not outside. The sun heats the thin Martian atmosphere quickly, so temperatures climb rapidly once the sun comes up. By the early afternoon, it may reach 50 degrees below zero out there. Every winter is long and cold at Dow Wallace.
Pilot's Log, May 2019.
After almost 3 really cold months, the temperature is slowly rising. This is my first night outside in several weeks. With frost on the ground, the dust levels are low and the sky above is crystal clear. Look overhead. There's our namesake, Antares, just to the south of the zenith and marking the heart of the starry Scorpion. The faint outline of the constellation Scorpius looks upside down to me because I grew up in Earth's northern hemisphere. Even more unusual than an upside-down Scorpion is a night sky with 2 moons. Deimos is smaller and more distant. Phobos is a closer, larger, and more fascinating moon. It shines 40 times more brightly than Deimos and is close enough for us to see its oval shape. Phobos is so close to Mars that it completes an orbit in under 8 hours. So the speedy Phobos rises in the west and sets in the east as it races through the starfield. Perhaps the most unusual object in the Martian night sky is Earth. Its appearance always catches us by surprise. It's almost as bright as Venus from Earth and blue. I have always enjoyed Earth watching, a habit I picked up on the space station, but I never thought our planet would look so beautiful from Mars.
Commander's Briefing, July 20th, 2019.
The crew of Antares 4 has been asked to make a statement on this, a very memorable day, the 50th anniversary of the Apollo 11 landing at the Sea of Tranquility. It was 50 years ago today that Neil Armstrong became the first person to stand on the moon. And soon after he returned to Earth, the United States committed itself to human exploration of Mars. And now, our international crew has landed on the red planet. Dao Vallis is our first foothold on a planet that can support human life. We are learning while we are here. We're learning to live off the land, and we're learning what it will take to make Mars humanity's next home world.
This is Mission Control, Houston. As part of the celebration, we have a message recorded on a CD-ROM by the Planetary Society in 1994. The noted planetary scientist, the late Carl Sagan, looked forward to your landing. These are his thoughts, taken directly from the old recording.
I don't know why you're on Mars. Maybe we're on Mars because of the magnificent science that could be done there. The gates of the wonder world are opening in our time. Or maybe we're on Mars because we have to be, because there is a deep nomadic impulse built into us by the evolutionary process. We come, after all, from hunter-gatherers, and for 99.9% of our tenure on Earth, we've been wanderers, and the next place to wander to is Mars. But whatever the reason you're on Mars is, I'm glad you're there, and I wish I was with you.
Surgeon's Log, September 2019.
We ate homegrown tomatoes today, and the taste was out of this world. As spring thaws our rocky red home, we congregate more and more in our greenhouse. The plants help us forget that temperatures still hover well below zero just outside our windows. The use of local resources also makes us feel as if we're really living off the land. There is genuine excitement and pride associated with finding water, extracting oxygen from the air, and making these tomatoes grow on Mars. The food we grow and water we find will also increase the food supply for future missions.
Geologist Log, October 2019.
Each day we set out with our geological tools to collect rocks and soils. Bit by bit, we are piecing together the history of our part of Mars. The robot explorers that came to this valley before us even returned a few kilograms of rock and soil. But we humans can spot the unique rocks, the rare but important samples. The rocks we were looking for were formed by heat and water and are reminiscent of a very special place on distant Earth, Yellowstone. In that beautiful park, heat from deep underground makes the water boil into geysers. Bacteria with unique adaptations thrive in these hot, mineral-rich waters. Where the water overflows and cools, crystals form, trapping and fossilizing the living creatures, preserving evidence of ancient life. This is one of the reasons we came to Dao Vallis, where volcanic heat and underground water came together early in the history of Mars. We've scoured this area searching for evidence of ancient thermal springs on the valley floor, but those rocks are scarce here. We are much more likely to find ancient hot springs higher up, in that distinct light layer near the top of this cliff. Before we leave this place, we must find a way to get up there. Maybe, just maybe, we can reach it from above.
Live Scientist Log, December 2019.
The more we learn about this planet, the more we realize how much it has changed. It's mostly dry and quiet now, but I can imagine a much more dynamic place, where the valleys flowed with sudden, gigantic floods of water as volcanic heat melted vast areas of ice. Was the atmosphere thicker back then, making the climate hotter? I wonder if it rained. I bet it did. All that water, most of it gone now, lost to space. Water that sustains life on Earth. I'm frustrated that we have yet to find the samples that will tell us of life here on Mars. I'm not giving up.
Geologist Log, January 2020.
To explore Mars thoroughly, we must take trips lasting several days. Our pressurized rover provides a range up to 500 kilometers. On this trip, we're going to Hadriaca Patera, the volcano just north of our outpost. Our rover makes good progress on the gentle slopes. At every stop, we collect samples of ash, a product of some of the oldest explosive volcanism on Mars. I'm glad we were here to identify and collect these samples. It's good to have humans in the loop to make decisions. We are honored to be here. I just survived a silly accident. At the last stop, an outcrop that looked solid broke away, and I took a long fall. Thanks to the low Martian gravity, I only suffered a bad sprain and some minor damage to my spacesuit. The accident creates a serious problem, though. On our way back from Hadriaca, I wanted to try sampling that intriguing light deposit high on the cliff face. Our time on Mars is growing short, and this may be our only chance. So we can't wait. I really wanted to do the rock sampling myself, but I trust my fellow crewmate to do the job.
This could be it, the sample we came so far to find. I'm not the geologist here, but I know I'm looking at some really old rock. Is this layer one of those thermal springs where life could have existed on Mars? Look at this rock, Houston. What are all these tiny round things? Pay attention, Earth. I could be holding proof that we haven't always been alone.
Engineer Meteorologist Log, March 2020.
These are the warmest days of the year. Each day, we have a temperature swing of over 100 degrees, and that's murder on equipment. An even bigger problem for equipment is the wind. Rising temperatures in the southern hemisphere can produce winds of hurricane speeds from 150 to 200 kilometers per hour. Such strong winds raise dust easily and can make severe dust storms.
Commander's Log, April 2020.
All around us, the dust clouds are continuing to grow. At first, the sky darkened just a little each day, but now I can see and even feel the motion of the winds growing ever stronger from the south. And as a pilot, I have some concern. Unfortunately, I feel that we must leave now, 1 month early, or risk missing the launch window for our return to Earth altogether. And if we miss that window, we would literally be trapped here on Mars for 2 more years. My crew is frustrated by the growing storm. It is with sadness that we have to hurry and close out Antares 4. We trust that the automated systems for the greenhouse will last at least until the Aldebaran crew arrives. The ascent vehicle is fueled and it's ready to go. The computer instructions have been transferred to the onboard systems. It's now time to take one final reflective look out the windows, and we can see the dust storm as it increases in intensity. We're ready for liftoff. Engine ignition. We have liftoff from Dow Vallis.
Pilot's Log, 2020.
Because the dust storm has cut our stay at Dow Vallis short, we must spend an extra month in Martian orbit, an orbit we share with Mars' 2 tiny moons, Phobos and Deimos. Earth scientists have puzzled over the origins of these 2 moons. They may be left over from the formation of Mars, or perhaps they were captured from the nearby asteroid belt. Phobos and Deimos have surfaces covered with debris from their many collisions with meteors. This loose material, called regolith, may be meters deep. Mineralogical exploration of both moons seems promising. Oxygen and other components might be synthesized from the regolith and turned into fuel and supplies for human exploration of Mars and beyond.
Surgeon's Log, June 2020.
After our Phobos flyby, we docked with the Antares 1, the spacecraft that will take us home. It has orbited Mars for 4 years, waiting to carry us back to Earth. I'm looking forward to the trip home. But as I stare out the ship's window, I can't help but think about the future. I wonder who will write the first Martian poetry, design the first Martian buildings, start the first Martian families. How long will we take to make this planet a real home? Not for a few years, but for millennia.
Mission Control, Houston.
On July 30th, 2020, the Aldebaran crew left for the Dauvalis outpost on Mars. By September, the Mars dust storm had abated and the skies over Dauvalis cleared, in time for the arrival of the Aldebaran mission in February of 2021. Meanwhile, the Antares crew landed at Cape Canaveral and soon returned to active duty, research, and teaching. Several of the Antares astronauts have requested assignment as primary instructors for the Arcturus mission that leaves Earth for Dauvalis in September 2022. As a new crew departs for Mars every 2 years, taking the place of the crew before it, we can proudly proclaim the human habitation of Mars has begun.